Welcome you all for engineering mechanics, chapter number 1, statics, lecture 1. So this is the syllabus for engineering mechanics for both civil and mechanical engineering. Since both department students are here, we are highlighting both the syllabus. Right? Both are same. First we will go through the syllabus for civil engineering mechanics syllabus. Right? System of forces, free body diagrams, equilibrium equations, internal forces in structures. It means trusses will come. Then friction and its applications, center of mass, vibrations, free vibrations. Right. So vibration is a new chapter for syllabus in the civil engineering syllabus. Right. Vibration. Actually, vibration is a very big chapter. Vibration, but in your civil engineering syllabus, you have free vibration only. Free vibration only. In the same time, single degree of freedom system only. Okay. Right. So there is a chance for multiple degrees of freedom. Right. There is a chance for forced vibration. There is a chance for damped vibration also. Right. But in all the cases, we have the starting level informations. Free or forced vibration, only free vibrations are. Damped or undamped, only undamped vibrations are. Single degree epidem or multiple degree epidem, only single degree epidem, are. Right? So why we are insisting again and again means we are studying the preliminary vibrations only for civil students, right? No need to worry about the vibration chapter. No need to worry about the vibration chapter. Okay, right. So whatever we are going to study is a preliminary vibration only, right? Don't worry, I will take care. Now come to mechanical engineering syllabus. The mechanical engineering, see, free body diagram, equilibrium equations, friction and its applications, then brakes, clutches. Actually, we will discuss brakes, clutches in the machine design, right? In the machine design. Then trusses, we will discuss here. Virtual work. Then KOM, DOM, kinematics and dynamics. Right? Then impulse and momentum, it also coming under dynamics part. Right? Both linear and angular. Right? Previously, we used to study only linear. This time we have to include angular momentum also, impulse and momentum for angular case also. Right? Then energy formulations, whether they are saying separately or not, we will study the energy formulations by default in the dynamics part. Right? Then Lagrange's equation. Right? So this is a new topic for mechanical engineering. Right? For civil engineering students, vibration is a new chapter. For mechanical engineering, Lagrangian is the new chapter. Okay. Right. Remaining everything is common for both civil and mechanical, right? No need to separate the topics, right? Whatever we are going to study in the engineering mechanics, right? All are pure fundamentals, pure fundamental things only. Okay. Right. See, in the overall, all of this here, in the overall, we are going to split the chapter into two. First chapter is statics, second chapter is dynamics, right? Only two chapters, right? In the first chapter, we will start with the degrees of freedom, equilibrium equations, basic laws. Basic law means law of parallelogram, Lam's theorem, right? Law of transmissibility, those things. Right? Resolutions, resultant of forces. So all the basics you will study. Then supports and support reactions. Already we have seen in the strength of material. Once again, we will go through that. Types of support, types of loads, types of beams. Right? Then we will use that information in the trusses. Right? Trusses, very simple chapter. 2 marks, mostly 2 marks question will be there. Trusses. Right? Then friction and its applications. So these are all coming under statics. These are all coming under statics. In the dynamics, there are 2 parts in the dynamics. First one is kinematics. This is kinematics. This is first part. In the first part, already we studied in our school days. equations of motion. V is equal to u plus at, v square equal to u square plus 2as, s equal to ut plus half at square, right? These equations. So it is coming under kinematics part. Kinematics part, right? First part of dynamics, right? Then second part is kinetics. This is second part, kinetics. In the under kinetics category, D'Alembert principle, work energy principle, conservation of energy principle, principle of impulse and momentum, conservation of momentum, collision of elastic bodies, principle of Fitzgerald work. At last, Lagrangian. So this is the syllabus coverage for engineering mechanics. Common. Right. It's a common topic. Right. For mechanical, special topic is Lagrangian. For civil, special topic is vibration. Okay. Right. That is not written in this slide. Right. Repeating, mechanical, Lagrangian is a special topic. For the civil, vibration is a special topic. At the end of the engineering mechanics, I will teach the preliminary level vibrations to the civil students. In the same time, mechanics welcome. Right? If you are interested, you can join. We will study in the theory of machines in detail, vibration details. Okay, right, fine. So we'll start with the degrees of freedom. Right. Any new joinees? Any new joining? Already we discussed degrees of freedom in the strength of material. Any new joinees there? New joinee who did not attend the okay, all right. Okay. I will start. Okay. Don't worry, I will take care. First topic is degrees of freedom. Degrees of freedom. See, degrees of freedom is nothing but possible motion. That's all. Possible motion. Take any object. Take your duster in the classroom. Right. Sir, I can move this duster in the x direction, sir. I can move the duster in the y direction, sir. These are all degrees of freedom. That's all. Very simple. So possible independent motions are nothing but degrees of freedom. Sir, I can move in the z direction, sir. That is also degrees of freedom. Sir, I can rotate about x-axis, sir. That is also degrees of freedom. That's all. Right. So degrees of freedom is very simple. It is nothing but possible independent motion. That's all. Possible independent motion. Right. We'll write the definition. Right. Or we'll write possible independent motions and object can have. That's all. Right. So when you are having the object in the space means 3D, right? Space means 3D. Right? You can move the object along the x direction. You can move the object along the y direction. You can move the object along the z direction. Okay, right? Y direction, z direction. It is our XYZ coordinate system, mutually perpendicular coordinate system. Okay, right. If we have a object like this, any object in the space, right? Any object in the space, right? It can move along the x direction. It can move along the x direction. It can move along the y direction. It can move along the z direction. These three are possible, right? So I'm going to write displacement along x direction. Displacement along x direction. Displacement along y direction. Displacement along z direction. Right? These three are possible in the same time. In the same time, right? The object can rotate about x-axis. The object can rotate about y-axis. The object can rotate about z-axis. Okay, right. Rotation about x, rotation about y, rotation about z. Right. Rotation about x, rotation about y, rotation about z. Right. Can anyone tell what do you mean by ux? Please unmute and tell me. What is ux? I told ux. Anyone, please? What is the name for the ux?
Displacement along x direction.
Very good, very good. Displacement or translation along x direction, right? Along, right? What do you mean by theta? Is it? Please answer. Anyone? Anyone, please answer. What is theta? Is it? Rotation about z-axis. Very good, very good. Rotation about z-axis. Okay, right. So this is along, this is about, right? That is a difference. Right? Now we are going to say that an object in space, an object in space has six degrees of freedoms. 6 degrees of freedoms. Okay, right. What are the 6? Now you know, right? 3 translation, 3 rotations. Right? 3 translation, 3 rotation. Right? Translation means what? Rectilinear displacement. Rectilinear displacement means what? Displacement along straight line. Okay. Right. 3 translation, 3 rotation. So technical name is translation. Translation means displacement. Displacement along straight path. Translation. 3 translations. And 3 rotations. So these 3 are translations, these 3 are rotations. Right. So you will give the full name for any one. For ux, I will give. Ux means already you have answered. Displacement along x-axis or x direction. Right. Here, theta x means rotation about x-axis. Okay. Right. So space means what? Space means, what are you trying to say? Space means, whenever you are saying space, it represents 3D. Space means 3D. Very good, very good. Right. Space is a keyword for 3D. Okay. Right. Is it clear? Details about degrees of freedom. Degrees of freedom. Is it okay? Possible motions for an object is nothing but degrees of freedom. What are the possible motions? Maximum 6 possible motions. Maximum 6 possible motions. Maximum. Okay. 3 translations, 3 rotations. Translation means displacements. Okay. Right. Then, just now I told that space is a keyword for 3D, right? Now, keyword for 3D is space. Space. 2D. 2D keyword, very, very, very important keyword because it is in your syllabus. Right? Planar. Planar. In plane. Along the plane. Thin cells. Along the cell wall. Plane stress. Plane strain. Axisymmetric. Right? So these are the keywords for 2D. Right? So these are all very, 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 very important for examination point of view. Right? So what is a keyword for 1D? Uniaxial. Uniaxial. Uniaxial is a keyword for 1D. Okay. Right. So this identification of 1D, 2D, 3D is very, very important. Reason is, in case of 1D, only one principal stress will be there. Only one principal stress will be there. Right? Then we will assume that sigma 2 equal to 0, sigma 3 equal to 0. It means second and third principal stresses are assumed as 0. Right. Then for 2D, sigma 1 and sigma 2. Two principal stresses will be there. Then we will assume sigma 3 is equal to 0, assumed value, right? In case of 3D, sigma 1, sigma 2 and sigma 3, all the three principal stresses will be there, okay? But they never say it is 1D or 2D or 3D, right? Based on the keywords we have to identify. That is why we are highlighting again and again, okay? So this is about 1D, 2D, 3D keywords, right?